Hey class, in today's lesson we are going to talk about arithmetic sequences, which is found in section 9-2 of your book. We are going to define, identify, and apply arithmetic sequences. So a little bit of vocabulary. It says an arithmetic sequence is a sequence where the difference between the consecutive terms is constant, and this difference is called the common difference. So in looking at this formula, we need to understand what each piece means because quite often, if we don't understand what the formula means, then we get confused on where we're supposed to place our numbers. So, just as a quick reference, A sub n is the total amount. So, the total of that sequence. A is the starting number. N is the number of terms. And D is the difference. All right, so let's kind of figure out what this means and how this will help us. So in example 1, we're asked to define if the series, or basically ask if the numbers will form an arithmetic sequence. Okay, so to figure out if something is going to form a sequence, you need to check to see if there is a common difference. So from 3 to 9, you are adding 6. From 9 to 12, we are adding 3. From 12 to 15, we're adding 3. So technically, because they are not all adding 3, then no, it's not an arithmetic sequence. Okay? On the next set, from 1 to 4, you're adding 3. 4 to 9, you're adding 5. 9 to 16, we're adding 7. And 16 to 25, you're adding 9. So again, because they're not all the same, then no, you do not have an arithmetic sequence. The only way for there to be an arithmetic sequence is if there is a common difference. So let's look at the try. In our try, we are adding 2, then adding 4, then adding 8. Once again, there are not common differences, so this is not correct. It's not a sequence. 1 to 5 is adding 4, 5 to 9 is also adding 4, 9 to 13 is adding 4, and finally 13 to 17 is adding 4. So yes, finally we have an example of an arithmetic sequence. In example 2, it says, what is the 100th term of the sequence that begins with 6 and 11? So this is where our formula comes into play. So I'm going to go ahead and rewrite the formula just to remind us what it is. So that's A sub n equals A parentheses n minus 1 times D. Okay, just as a reminder, A sub n is what that 100th term is going to be. So what that last term is, and that makes sense because of the little n that's next to it. That n reminds us that it's the number at that term. Okay, A, remember, is the starting number, n is our number of terms, and D is a difference. So let's first start by finding A, n, and D. So A, remember, if that's our starting number, A is 6. N is the number of terms. We've asked for 100. And D would be the difference between the numbers. So from 6 to 11, you get positive 5. Now, understand that if we were subtracting, for example, if it had said 11, then 6, we would have used a difference of negative 5. But we're going to use, in this case, positive 5. So let's go ahead and start substituting in the information. A sub 100, so in other words, a 100 term will be 6 times 100 minus 1 times 5. If we keep going, that's 6, and it's not times. I missed a part of the formula, it's plus. All right, so 6 plus 99 times 5. Let's see, 99 times 5. I'm grabbing my calculator, so let's see. 99 times 5 is 495. So our 100th term is going to equal 501. Okay, so let's practice that again on the next example. And actually I spoke too soon. This is just a try part 2 or example part 2. So it says, what are the second and the third terms of the arithmetic sequence? So we have a sequence that's already formed. It told us that it's an arithmetic sequence, which is key information. But we need to be able to find what the second and third terms are. So what we have to assume is, because they told us that this is an arithmetic sequence, that the differences are all the same between the numbers. Whatever the differences are, so we'll use D as the letter for difference, okay, that they are all the same. So since that is the case, we'll set up the equation as 82 equal to 100 plus 3D. And just to be clear, the reason why we're doing that is because if you remember the formula from the previous page, it says A sub n equals A plus n minus 1 times D. So A in this case is 100. It's our first term. 82 is the last term of the sequence. Not necessarily, but for now it is the last term of our sequence. And we use 3D to show the number of differences. Okay, so from here we can continue to solve. So if I subtract 100, I will have that 3D is equal to negative 6. Oh, sorry, negative 18. Sorry. Last, if I divide by 3, then D equals negative 6. So from 100 to 82, we are subtracting 6 every time. So 100 minus 6, so the second term of the sequence will be 100 minus 6, which is going to give us 94. And if I subtract 6 from that again, I'll get 88. And that makes sense because if I subtract 6 one more time, I'll get 82. So once again, we're still using the same formula, okay, from the first problem, just to find the second and the third terms. So let's actually now try this or put this into practice. So on the first try, it says, what is the 46th term of the sequence? So here we go. A sub n equals A plus n minus 1 times the difference. We don't know what the last term is, so we're going to write A sub 46 to represent the 46th term. A is 3. That's the first number in the sequence. Plus n is the number of terms, and the number of terms is 46. So 46 minus 1, and the differences we're adding 2 every time, so it's going to be times 2. So 3 plus 45 times 2 is going to give us 3 plus 90. So the 46th term, oops. So the 46th term is 93. And we'll leave our answer just like that. Okay? Let's look at the next try. So again, we're trying to figure out what the second and third terms are of the sequence that's already started. So remember, these should all be common differences, right? So again, A sub n equals A plus n minus 1 times the difference. A sub n, meaning the last number, is 125. A is the first number, so that's 80. And at this point, we just need to figure out how many differences there are, and it's 3 differences. Okay, subtract 80. And we are going to get 45. Next, if we divide by 3, we're going to get 15 as our difference. So every time we're going to add 15 to our numbers. So the second number should be 80 plus 15, which is 95. And then the next one after that will be 95 plus 15, which is 110. All right, so in example 3, we're going to use still pretty much the same thing, except now we're going to add on arithmetic mean. And it's not really difficult at all. Finding the arithmetic mean is honestly just adding the first and the second and dividing by the difference. So in this case, we're going to add we're going to add 15 plus 59 and then divide by 2. In other words, we're finding the average of the first and last number to find the middle. So 15 plus 59 would produce 74. And if we divide that by 2, that's going to give us 37. So our missing number is 37. Very straightforward, very simple, very easy. We're done. So let's do the try. In this case, it says the 9th and 11th terms of an arithmetic sequence are 132 and 98. What is the 10th term? So they put it in word format, but it's still the same thing, right? Because the 9th term is 132. We don't know what the 10th term is, and the 11th term is 98. So again, we add 132 plus 98 and divide by 2. So 132 plus 98 is going to give us 230. And 230 divided by 2 should be 115. So 115 is our 10th term. All right, so we're going to bump it up one more level. So in example 4, now we have a word problem. It says the number of seats in the first 13 rows in a section of an arena form an arithmetic sequence. And it's important that they tell you that it forms an arithmetic sequence because it could do something else. Row 1 has 14 seats. Row 2 has 16 seats. How many seats are in row 3? So again, using our same equation, right? The equation A sub n equals A plus n minus 1 times the difference. Okay, we need to be sure that we can figure out what each number means. So remember, A sub n is the number at that last term. So in this case, they're asking how many seats are in row 13. So A sub 13 would be what we're looking for, A sub n. Okay, A is the first set. So the first number will be, the first number for A is going to be 14 because that's the number of seats in that first row. And then N we know is going to be 13 because that's how many rows they're talking about. And then last, D is the difference between the amount of seats in row 1 and row 2. And so from row 1 to row 2, you added 2 seats, so D is 2. So now we're going to do a substitute. So what we're going to write is A sub 13 equals 14 plus 13 minus 1 times the difference, which is 2. If I keep going, that's 14 plus 12 times 2. So that's 14 plus 24. And so last, that is 38. So there are 38 seats in row 13. And because this is a word problem, I want a word answer or word explanation. So write 38 seats in in row 13. Okay, so we'll do another one just like this. So it says the number of seats in the first 16 rows is in a curved section of another arena form an arithmetic sequence. If there are 20 seats in row 1 and 23 seats in row 2, how many seats are there in row 16? So again, we're just going to write what we need to know. So A sub n is really going to be written as A sub 13. A is the amount of seats in the first row, which is 23. N is the number of rows, so there are 16 rows. And D is going to be the difference of the first row and the second row. So in row 1, there are 20 seats. I wrote that wrong. There are 20 seats in row 1. Sorry. 20 seats in row 1, 3 seats in row 2. So the difference is you're adding 3. So if I substitute those numbers, then we're going to have 20 plus n is 16, so 16 minus 1 times the difference, which is 3. So that's going to be 20 plus 15 times 3. 15 times 3 is 45. And 20 plus 45 is 65. So there are 65 seats in row 16. And we are done with our lesson. So guys, once again, if you have any questions, please be sure to check with me for tutoring. Otherwise, we are done.